G'day YouTube, Warbles on a lot here with what's very definitely going to become a mad scientist video. As you may have heard, it's not actually easy to make a map of the earth that we live on which can withstand being put to the test by the sort of people who don't stay where they're born, but rather they want to travel around the place. And when they go using maps and compasses, so they know what direction they're going in, they know how far they're going, how fast they're going, and they know they're going in a straight line, they get to check up all your distances. So if you're going to draw a map of the world, it's got to be right. And people have been trying to draw proper maps of the world which are right for the hell of a long time. Thousands of years people have put into the effort. One method is to imagine you've wrapped a sheet of paper around your entire globe, map your continents looking at your grid lines parallel, and then plot that out on a flat sheet of paper. All the compass directions are shown as straight lines. Places of similar latitudes appear at the same height. Distortion is greatest around the poles. Cylindrical projections are often used for world maps and almost all navigation charts. The Mercator projection of 1569 is a famous example. As opposed to a conic projection, in this system developed by the ancient Greeks, maps are derived from a projection of the globe onto a cone with its point above one of the poles. Distortion increases between the parallels that are nearest the tip of the cone, so this type of projection is most suited to mapping the mid-latitude regions that are larger from east-west than they are from north to south, such as Canada. Then there's what they call an azimuthal projection, azimuth. A portion of the Earth is shown as a flattened disc, placed at a tangent to the globe with latitude and longitude lines extending from the point of tangency, for example, the North Pole. As distortion increases with distance from this point, these projections are best for maps of the polar regions and whole continents. Azimuthal equal area projections. Okay, so there's some of the problems involved in making a map of the rotating Earth. However, if one attempts to try and map the flat Earth model, then it really only sort of halfway works if you assume that what's shown in the frame is about the boundaries of your flat Earth, with a vertical edge that you fall off if you try to sail out into the Atlantic. And a setup like that will sort of almost work for your compass within that limited little small area of the world that, say, the ancient Greeks knew about or the Egyptians knew about. Perhaps you could say that before they invented sundials, people thought that the world was flat. This is what they thought they were living on, perhaps. Certainly the Chinese knew about the compass back there then. So the prime deficit or difficulty with your flat Earth map that only includes the ancient world known to the Egyptians and the Greeks is that while it allows your compass to point more or less towards the North Pole, it's not much good once you get south of the equator, because it envisions too small a surface area to encompass all the rest of the known geography of the planet. And therefore you come up with a system where you wind up having the Earth as envisaged as being, well, something that looks a bit like this, where you've got the North Pole at the centre of a disc. You've got your Arctic Circle. You've got, can we see that there? Yeah, you've got your Tropic of Cancer. You've got your equator, your Tropic of Capricorn, and then if you come right the way down to here, you've got your Antarctic Circle, and then the actual South Pole. In order to make everything work out right, the South Pole, it has to be a ring of ice which has a south magnetic field. And the north magnetic field is here, and that way your compass is going to point north no matter where you go on the flatness of the Earth as envisaged by people who believe in this concept. Okay, well, I got this far in trying to draw a flat Earth map of the world because I'm planning on making a video which requires me to have a map of the flat Earth to use as background prop in a video where I want to compare a few predictions of the flat earthers with what is observed to occur in my front yard, or maybe my neighbour's paddock. Haven't quite figured out where I'm going to conduct this masterpiece yet. So here's a problem that I've struck. If I take the distances with a set of dividers and the magnetic bearings, or the grid bearings, between north and any particular direction, and I try and transfer this information onto the flat Earth map, okay, the inside area inside the equator, it doesn't look too bad. But once you get on the south side of the equator, you wind up with all your continents pointing out towards the ice wall, as they call it. And when you do that, all of the distances between, say, Sydney and Cape Town, or Cape Town and what do we got at the very end down there? Santa Cruz, or Montevideo. All your distances down here on the bottom half of the planet, they all blow out to be absurdly ridiculous figures. At least according to the notebooks and the data of the people who've spent 500 years sailing and 100 years flying around and over and about the Earth. Apparently what I'm trying to do is not remotely original. Somebody called Gleason came up with a flat Earth map which looks a bit like what I'm having a crack at. What I've decided to do is take this cylindrical Mercator projection, which gives us degrees of azimuth, which will satisfactorily run all the way around the ice wall. And this particular map has a grid which is marked off in 15-degree squares. So each grid square is 1 hour of time. And that is going to be a relatively useful feature of the map. So the plan is now to transfer all of the grid coordinates from this map, featuring meridians of longitude running from the North Pole to the South Pole, and parallels of latitude running up and down the planet, kind of thing, as can be demonstrated thus. Whereas the, quote, best flat Earth map representation I can come up with, it's going to have radials or radians of longitude, and it's going to have circumferentials of latitude. And the continents are all going to be sort of pushed out of shape, but it'll give you a disc world style of a flat Earth, which has concentric, equator, and tropics. And that's going to be a little bit important as well when I get around to making the video, which should be happening on Sunday, I hope. All right, so you can regard that as a definite warble tease. Hopefully it'll be done by next time you see it. Warbles on a lot to YouTube. Ciao.